History of ozone layer. In the mid-20th century, scientists discovered the existence of a layer of ozone in the Earth's atmosphere, which played a crucial role in protecting life on our planet from harmful ultraviolet (UV) radiation emitted by the sun. The ozone layer acted as a shield, absorbing most of the UV radiation, thereby preventing it from reaching the Earth's surface, where it could cause severe health issues such as skin cancer, cataracts, and immune system suppression. However, in the 1980s, researchers made a startling discovery: a significant decline in ozone concentrations over Antarctica during the southern hemisphere spring. This depletion was so substantial that it became known as the ozone hole. Initially, scientists were perplexed by this unexpected phenomenon and sought to unravel its mystery. The first step in solving the ozone hole mystery involved understanding the chemical processes occurring in the atmosphere. Researchers identified human-made chemicals called chlorofluorocarbons, CFCs, as the main culprits. CFCs were widely used in refrigerants, air conditioning, aerosol propellants, and foam-blowing agents. Once released into the atmosphere, these chemicals were broken down by sunlight, releasing chlorine and bromine atoms. The released chlorine and bromine atoms were incredibly reactive and acted as catalysts in the destruction of ozone molecules. Each chlorine or bromine atom could potentially break down thousands of ozone molecules before being removed from the atmosphere. This catalytic destruction process led to a significant thinning of the ozone layer, resulting in the formation of the ozone hole. The ozone hole's discovery spurred worldwide concern about its potential consequences. Apart from the immediate health risks of increased UV radiation, there were worries about potential impacts on climate, weather patterns, and ecosystems. In response to these mounting concerns, the international community came together to address the issue. In 1987, the Montreal Protocol was adopted, an international treaty aiming to phase out the production and consumption of ozone-depleting substances, including CFCs. The protocol was one of the most successful environmental agreements in history, showing how global cooperation can effectively tackle complex environmental challenges. Over the years, thanks to the collective efforts of nations around the world, the emissions of ozone-depleting substances have been significantly reduced. As a result, the ozone layer has shown signs of recovery, providing hope that the ozone hole's expansion can be halted and eventually repaired. The ozone hole mystery serves as a poignant reminder of the importance of understanding the consequences of human activities on the planet's delicate environmental balance. It also demonstrates the power of international cooperation and action in safeguarding the Earth's atmosphere for future generations. As we continue to face new environmental challenges, the ozone hole mystery remains a crucial lesson in our journey towards preserving and protecting our planet. Now we talk about relationship between increasing population and ozone layer depletion. The relationship between increasing population and the ozone hole is primarily indirect but interconnected through human activities and their environmental impact. As the global population increases, so does the demand for goods and services. This, in turn, leads to higher industrialization and consumption of products that may release ozone-depleting substances, ODS, into the atmosphere. These substances, such as chlorofluorocarbons, CFCs, and halogens, are potent contributors to ozone layer depletion. Growing populations also lead to increased energy consumption, which can result in higher emissions of greenhouse gases like carbon dioxide. While CO2 primarily affects climate change and global warming rather than the ozone layer directly, climate change can influence atmospheric circulation patterns. It's essential to note that efforts have been made to address the ozone hole issue through international agreements like the Montreal Protocol, which has been successful in reducing and phasing out. In summary, the increasing population indirectly affects the ozone hole through its influence on human activities and emissions of ozone-depleting substances and greenhouse gases. Addressing these issues requires continued global cooperation and sustainable practices to protect the Earth's ozone layer and mitigate climate change. Now we talk about its cultural influence. The ozone hole is not directly linked to culture in the sense that it is not a cultural phenomenon. Instead, it is a scientific and environmental issue resulting from human activities. As previously mentioned, the ozone hole is primarily caused by the release of human-made chemicals, such as chlorofluorocarbons, CFCs, which deplete the ozone layer. These substances are often used in industrial processes, consumer products, and other human activities that are not inherently tied to any specific culture. However, cultural factors can indirectly influence the ozone hole and its potential solutions. For instance, different cultures may have varying levels of awareness and concern about environmental issues, including ozone depletion. Cultural attitudes toward consumerism, waste management, and sustainability can also impact the use and disposal of ozone-depleting substances. Addressing the ozone hole and other environmental challenges requires global cooperation and unified efforts from people of diverse cultures and backgrounds. International agreements like the Montreal Protocol demonstrate how cultural diversity can come together to address shared environmental concerns and protect the planet for future generations. While culture itself may not directly cause the ozone hole, it plays a role in shaping individual and societal attitudes and actions towards the environment. By fostering a culture of environmental awareness and responsibility, we can collectively work towards safeguarding the ozone layer and creating a sustainable future.